All right, so let's get back to the meeting. We were talking about like what happens when you have bases which are like powers of each other. For example, 16 is the power of 2. Why does this make conversion between the two bases convenient? Well, if you look at base 2 algebra and we have something like, I don't know, 1 times 2 to the 6. Well, I don't know, really like a chain of numbers like this or something. And nothing after that, 0 times 2 to the 0. If we go from left to right, or if we go in order, okay, I should write this there. Then this is a number in base 16, which is just, we can compute this is 8 plus 2 plus 8 plus 2, which is just a in base 16. And this, if we factor 2 to the 4th out of this, 2 to the 4th times 2 squared plus 1 is equal to digit 5, 0 in base 16. But the thing is, we're guaranteed that if we group them in power by powers of like 2 to the 4th, like this, then we will get all the digits one by one. So the first digit is 5, next digit is a. So that's how you convert to base 16. Like, okay, let's just try something like really random and convert to base 16. So we take them in groups of 4 like this. The reason being that we can, like, the way to understand it is like that, like 2 to the 4th factoring out stuff we did. And then if the leading digit doesn't fit in a group, or leading digits, I should say, we just like take them as if there's like we've had a bunch of zeros here, like as if that's what we read them as. So what does this give us? 8 plus 1, 9, right? We just read this in base 2. We don't like change it in any way. We just make it a second digit. So that would be 2 squared plus 2 is 6. This would be 7, right? Yeah. And this would be just 1 base 16. So yeah, that's how you convert from like powers of bases to each other. This can generalize to any power of 2 and any power of like any base to it's like exponent root. Okay, so anyways, enough of that. Let's convert 18310 in base 16. So yeah, go ahead and do that. And once you're done, you can send me your answer. All right, so I see I've gotten all right answer. Should be. So first step, as I've said before, So we should have B is our first digit. 23 is our remainder. Or not 23 is not our remainder, sorry. 7. Just B7, 16. So yeah, not that many digits since we converted to bigger base. And yeah, that's just quick overview, I guess, of base conversion. Now we can practice adding and subtracting numbers. As you could imagine, adding numbers is pretty much the same as in base 10, except the regrouping is like different because in base 10, you regrouped once you reached 10, since that was when it carried over to another power of 10. And the same thing it can be said of bases like 5 and 6. If you add like 2 plus 3 when you like, go to do the vertical addition, if you would add a 1 to the next place and then have a 0 down below, it's really just like adding 10, except adding in base 10, except it revolves around whatever number you have. Like if your base is going to be base 6, you regroup every time you get something that adds to more than 6. Same thing with any other base, just like that. And the digit you put down um, below would be equal to the thing mod 6, where it would have been the units digit mod 10 before. Similar thing for multiplication, because like these are all like basic arithmetic operations, just redefined in terms of bases. So yeah, there's some arithmetic practice. I guess I'll just do these in class. So we convert 14 and 70 equals 14 times 5 to base 5. Okay, well, this is easily 10. 14 over 5 is 2, 4, 5. Well, what's 24 times 10 in base 5? This is just like, really, it's just 20, it's just 240. Like, I don't know why I wrote that. It's just 240 is equal to this plus that is equal to our desired answer, 70. So really the point of this is just to show that like it carries over. That multiplication, addition, subtraction are just as valid in other bases as they are in base 10. It's not a unique thing at all, base 10. Now, given that, what's 10 in base 5 times 43 in base 5 and express your answer in base 5? This should be pretty easy if you know how things are starting to work now. But yeah, just go ahead and do that. You can type your answer in chat when you're done. And we are just doing 10 base 5 times 43 base 5. I'd like to clarify we aren't doing anything else right now. Yeah, it's just 430 base 5, right? Because really just this is just like the same base 10, except like we just add a 0. It's the same, it represents the same thing. It's basically 10 just represents that you add like another digit because you multiplied it by the base. Same thing with like quote 100 base 5 and more. As we said, addition and subtraction work the same. We need to be careful. You need to carry the base, not 10. So 145 plus 42. If we do everything in base 6, it's be 7. So 1 mod 6, 1 carries over. 9, that's 3, and then another 1 carries over. So it should be like 231, 6, if I'm correct. Similarly, in subtracting, you just borrow the base instead of borrowing the 10. I mean, after addition, this should not come as a surprise. So let's go on left to right. We borrow this, our base is 6. So we just do this. 134 base 6. Now we have some exercises to calculate the following. Looks like Nathan has already completed the first one, so I'll go over that really quick. So we just want to double 3, 3, 3, 6. Sorry, there's a lot of overgrouping here. 1. So the 1110 base 11110 base 6 or 3 ones and a 0. And anyways, let's do the rest of these problems too in a similar fashion as I just showed you with all these examples. And yeah, just privately message me once you're done. Second one's just uh um base 5, everything. There's 8, so this is 14, base 5. We can also note that like this is kind of quote quote 200 minus 1, at least it is in base 5, to like making that observation to greatly speed things up. But yeah, you can just do it using normal or grouping. See, it's 14, 5. And now I'll let you do the different bases or subtraction of different bases, and as it says, answer in base 10. Now you can do this one in any way you want, but since it's in different bases, you will most likely have to do a bit of conversion, maybe, maybe not. All right, so yeah, I see answer for this one. What do we do here? 2 times 16 squared minus 12 squared plus 3 times 16 minus 12. Last one cancels out since it's just powers of 0 and the digits are all the same. 2 times, okay, so that would be 48 times 4, right? Oh, no, 28 times 4, sorry, what am I saying? That would be 112 plus 3 times 4. 224 plus 12 is 236, yeah. So 236 is the answer to this. I just did some like exponent subtraction. Oh yes, right, to this part. So I would like to mention Alchemist to you. A lot of you have art of problem solving accounts, especially since you're like gonna take the AMC 8, right? So Alchemist at this level, at least for AMC 8, maybe potentially AMC 10 too. Alchemist is a good problem solving practice tool. Recently they did add like a bunch of intermediate division problems, so those could like those are probably more difficult, so I'd say stick to mainly like the introduction stuff.
Yeah,
So quickly let me show you this.
definitely do a lot of this.
So when you go into art of problem solving, you go to artofproblemsolving.com/alchemist. As you can see, I must have already clicked in here, but first, of course, make sure you're signed into your account so so you can use it. Basically, what it does is it gives you like a bunch of problems or problem after problem for you to solve. Shoot, I forgot how you. It's been so long since I've used this. I don't exactly remember how you
It
change this. All right, it was
change
here,
focus
and
and
then
then
you can click
algebra
like
and
anything you want to. I don't know, like whatever, anything. Like if you just want to do practice random topics, like let's see, this should be 50 times 0.15. Should be
that
7.5, I
is
think. And you can see it says like correct, and then after this it'll give you more problems. As you see, sometimes they're like quote mystery problems, and yeah, and you get 2 tries. So like on the first try, it'll tell you if you're right, it'll just automatically take you to the answer. If not, it'll say wrong answer, you can try again. And it has like a lot of like stats for it, like stamina, resilience, all of this stuff. This is like if you like answer right on the second attempt. This is like, of course, answering right on the first try. I don't exactly remember what power and stamina are, but I think they do have to relate to how often you do it. Although like you should just use it as a practice tool. Don't focus on like leveling up all of these stats. Use them as a very like crude and rough indicator of where your level is at for each topic. Um, but other than that, yeah, that's basically what Alchemist is. It has a lot of problems taken from AMC's math counts, etc. And for the AMC 8 level, I would recommend just going through like these topics. Although sometimes like hard problems can even come up in these. But yeah, I think these are a bit too advanced for, especially for AMC 8. Maybe not for the AMC 10. But yeah, it's a cool practice tool, and art problem solving also has like other good resources like math counts training for the win that
they,
you should check out. So yeah, that's basically what I had to say about it.
I actually want to try to play fancy or whatever.